Hello students, welcome to Team Curiosity e-learning classes. In this lecture, we are going to explain about composite function. Before going into the topic, let's take an example for better understanding. Consider the set A, which is the set of all students who appeared in the class 10 board examination. Each student appeared in the board examination is assigned with a roll number by the board. This roll number is written by the student in the answer script on the examination. In order to have confidentiality, board assign a code number to each roll number. Let B is the set of all roll number and C is the set of all code number. This gives rise to two functions, function f from A to B and function g from B to C. From this, we get to know f of A is the roll number assigned to student A and g of B is the code number assigned to roll number B. So, in this process, each student assigns a roll number by function f and each roll number is assigned a code number by the function g. By the combination of these two functions, each student eventually assigned a code number. This leads to the definition of composite function. That is, let f is a function from set A to B and g is a function from set B to C. The composition of f and g denoted by GOF is defined as the function GOF from A to C given by GOF of x is g of f of x for all x belongs to set A. The Venn diagram for this operation is as follows. Here A is a set having x as one of its elements. F is the function from set A to set B. Operation of this function on x gives rise to f of x, which is an element in set B. G is a function from set B to set C. Operation of this function on f of x gives rise to g of f of x, which is an element of set C. Combination of these two operations f and g gives rise to GOF, which is establish a relation between set A and set C. This type of function are called as composite function. Now, let's take the first example. Let f is a function from set containing the elements 2, 3, 4, 5 to the set containing the elements 3, 4, 5, 9. And g is a function from set containing the elements 3, 4, 5, 9 to set containing the elements 7, 11 and 15. And the function f defined as f of 2 is equal to 3, f of 3 is equal to 4, f of 4 is equal to f of 5, which is equal to 5. And function g defined as g of 3 is equal to g of 4 is equal to 7 and g of 5 is equal to g of 9 is equal to 11. We have to find GOF. The solution is, from the given data of the question, GOF of 2 can be written as g of f of 2, which can be written as g of 3 as f of 2 is equal to 3. Now the solution of g of 3 is equal to 7. Similarly, we can write GOF of 3 is equal to g of f of 3 is equal to g of 4 as f of 3 is equal to 4. Then g of 4 is equal to 7. Now GOF of 4 is equal to g of f of 4, which is equal to g of 5, which is equal to 11. Similarly, GOF of 5 is equal to g of f of 5, which is equal to g of 5, which is equal to 11. Now come to the second example. F is a function from set r minus 7 by 5 to set r minus 3 by 5, which is defined by f of x is equal to 3x plus 4 by 5x minus 7. And g is a function from set r minus 3 by 5 to set r minus 7 by 5, which is defined by g of x is equal to 7x plus 4 by 5x minus 3. Then we have to show that FOG is equal to IA and GOF is equal to IB, where A is equal to r minus 3 by 5 and B is equal to r minus 7 by 5 and IA of x is equal to x for all x belongs to A, IB of x is equal to x for all x belongs to B. Here IA and IB are called identity function on set A and B respectively. Before going to the solution, let's have a brief knowledge about identity function. Identity function is a function which returns the result same as the argument. That is, if x is a element of set X and Ix is the identity function, then Ix of x is equal to x. So the operation of identity function Ix on x gives the result x. So we can say if the result and argument are same after the operation of the function, then that function is called identity function. Now come to the solution. Here we have g of f of x is equal to g of 3x plus 4 by 5x minus 7, which is equal to 7 whole into 3x plus 4 by 5x minus 7 plus 4 whole divided by 5 whole into 3x plus 4 by 5x minus 7 minus 3, which is equal to 21x plus 28 plus 20x minus 28 whole divided by 15x plus 20 minus 15x plus 21, which is equal to 41x by 41, which gives the result x. Similarly, FOG of x is equal to f of 7x plus 4 by 5x minus 3, which is equal to 3 whole into 7x plus 4 by 5x minus 3 plus 4 whole divided by 5 whole into 7x plus 4 by 5x minus 3 minus 7. By solving this, we get 21x plus 12 plus 20x minus 12 whole divided by 35x plus 20 minus 35x plus 21, which is equal to 41x by 41, which gives rise the final result x. Thus, GOF of x is equal to x for all x belongs to B, and FOG of x is equal to x for all x belongs to A, which implies that GOF is equal to IB and FOG is equal to IA. From this, we conclude that GOF and FOG also behave as identity function in this problem.